Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, as always, Ricardo Lopes, and today I'm joined by Dr. Simon Garnier. He is an associate professor of biology at the New Jersey Institute of Technology. He is the head of the Swarm Lab, an interdisciplinary research lab that studies the mechanisms underlying collective behaviors and swarm intelligence in natural and artificial systems. His research aims to reveal the detailed functioning of collective intelligence in systems as diverse as ant colonies, human crowds, and robotic swarms. So, Dr. Garnier, welcome to the show. It's a pleasure to everyone.
Thank you for having me.
So, just start perhaps with a general definition or to have a general sense of what we're going to talk about here today. What is swarm intelligence?
So essentially it's the idea that you take a bunch of simplified units, things of like ants, which by themselves are not particularly capable of much. But when you put them together and you have them coordinate their activity and cooperate, they're capable together of achieving things that are much greater than what any of the individuals in the groups could do by themselves. So that's the general idea of swarm intelligence. And it comes with also the idea that there's nobody necessarily in charge inside the group. So nobody is organizing the colony is self-organizing from the interactions that are happening between the different individuals in the colony. So that's the general gist of it.
Mm-hmm. Are there any set of principles that drive swarm intelligence?
Yes, so the sort of central theory behind the idea of swarm intelligence is that theory of self-organization, which is this idea that you don't need to have anyone in charge. You don't need to plan anything ahead of time. You can actually create organization and solve problem collectively simply through the interaction that are created between the individuals. So nobody necessarily is in charge, but everybody reacts to their local environment, reacts to what's happening around them. And if these interactions are properly set, that's going to create a global organization at the level of the group. So that's the general theory behind swarm intelligence.
Mm-hmm. Does the intelligence of the individuals who compose the swarm matter?
I mean, it does, right, to some extent, because each individual, you can see it as a unit of information processing, a little bit like the neurons in your brain, right? Each neuron by itself is capable of some processing, but where the intelligence, the swarm intelligence appears is when all of these units start to connect with each other. Because then the information is not simply treated at the level of the individual, it starts to be propagating inside the system, and it will give rise to greater level of cognitive processing outside of the individual. So to some extent it matters because each individual will process some of that information, but what makes that processing really valuable is through the interaction with others, because then information can propagate and be treated in parallel by multiple units at the same time.
Mm-hmm. Could you give us some examples of biological systems of swarm intelligence?
Sure. I mean, probably the most studied one, or the one that started it all, if you want, is that behavior that, I don't know how much you know about ants, but a lot of ant species, the colony needs to get food, the workers go out of the nest, look for food sources, and then if someone finds a food source, it will go back toward its nest and lay behind it a trail of pheromone. So pheromone is like a chemical substance that you lay in the environment. And that trail of pheromone will stimulate other workers to go outside the nest, but also guide them back toward the food source. These workers, in turn, once they have found the food source, when they come back to the nest, if they like the food source, they lay more pheromone, they reinforce the signal, which drives even more workers to come out of the nest, go explore the food source, and then in turn reinforce that information. And if the food source is of really good quality in comparison to other food sources available in the environment, through that reinforcement of the signal, that collective reinforcement of the signals, it ends up being selected as the main food source that the colony is exploiting, and the other food sources that are poor quality in the environment are abandoned. So it's a very simple mechanism where you're just reinforcing information that, or you're reinforcing signal that you like, that encourage other individuals to go check out the source of that signal, and they like it, they reinforce the signal themselves, which encourages more individuals. And then little by little, the colony ends up selecting in the environment the best of the food sources. And yeah, that's one example. Very simple, when nobody is really in charge, everybody is just giving their opinion, if you want, about the quality of a particular sources of food in the environment. But through that collective interaction and collective activity, the colony manages to select the best of all the food sources in the environment.
Mm-hmm. Does the same happen in human societies?
Yeah, I mean, essentially, every time you have a recommendation system, like you go on Amazon to buy a new laptop, let's say, people who have bought that laptop before may have come back and they could have left positive or negative reviews about the laptop, and that's going to influence your opinion about whether you should buy or not buy that laptop. And the laptops where there is more positive reviews will end up attracting more customers. And then the customers as a whole, population, if you want, will end up collectively selecting which might be the best laptop to buy right now. That makes sense. So it's exactly the same principle. It's just you have a social signal in the environment that encodes some information about what other people have thought of the quality of a particular object. And by attracting you toward that object, and if you like it, you also put your own signal out, that may encourage other people to buy that same product. And collectively, as a society, we select the product we think are the best. I'm not saying we always do it right, but the idea is that in this kind of scenarios, you will select the technology that people like the best, or the one that has improved the life of people the best with this recommending system.
Mm-hmm. So what is collective decision making?
Well, that's a good question. The first question is what is decision making, right?
Yeah.
Because it's a really complicated question. Because when you observe, in my job, right, I study animal behavior. I can't ask the animal, have you made a decision? Have you made a choice here? All I can see is whether the animal or the group of animals has gone to a particular place more often than not. So decision making in our case is really that is, do the group of animal, the group of object that we're looking at, does that group ends up more often than chance at a particular place? And so that's very, very vague, but it's a very actionable definition of decision making. And collective decision making is just applying that process to groups, right? That concept to group. The idea is that each individual in the group may have some opinion about the choice between two options, let's say, in the simplest case. And some of the group will maybe prefer option A, some of the group will maybe prefer option B. But because of these interactions between the individuals that prefer A may be able to attract some of the individuals that prefer B toward their side, if you want, because the group wants to stick together. And so through that mechanisms of interaction inside the group, most of the individuals end up at one option, even though sometimes it's not their originally preferred option.
Mm-hmm. So I'm not sure if any of the examples you've given us correspond to this sort of phenomenon, but what is aggregation behavior and how does it contribute to collective decision making?
So, I mean, aggregation behavior is simply the idea that the agents that you're looking at, the animals you're looking at, tend to cluster in the environment. And usually you measure that by looking at whether the distribution of the object in the environment or the animals in the environment is more clustered than what you expect by random chance. Okay? Now, the reason why aggregation is so important, the reason why you need the organisms or the object to come close to each other is because it facilitates the exchange of information. And collective intelligence and swarm intelligence require that the organism interact with each other. And so the more aggregated they are, the better they'll be at transferring information between each other, the better they'll be at collectively processing that information, and therefore the more likely you see emergent processes appear and things like collective decision making, etc. If the organisms are too dispersed in the environment and don't interact with each other, then there's no collective intelligence possible. Again, if I take the example of your brain, right? If I take all the neurons and I just separate them, I have like your 90 billion something neurons, and I just separate them and they don't interact with each other, then there's no more intelligence. You need to have them close enough to each other so that they can talk to each other, if you want, in order for the information to be transferred and processed by the group.
Mm-hmm. When it comes to biological systems, are any of the kinds of behavior that contribute to collective decision making heritable, or is it just the organism responding to, I don't know, perhaps the behavior of other individuals of that particular society, to some ecological conditions or factors, or I mean, how does it work exactly?
So I guess it's a complicated question, right? Because when we talk about heritability, the further away you are from the genes, right? So collective behavior is very far away from the genes in terms of like levels of observations, right? And so it becomes increasingly complicated to statistically demonstrate that a collective behavior is encoded in a set of genes that is then passed on to the next generation. However, these collective behaviors are the product of the individual behaviors and the interaction between the individuals and the way individuals react to these interactions, right? So a lot of these individual behavior, you can trace back their genetic origins. Like, for instance, simple things like how sensitive an organism might be to this, this pheromone we're talking about, how capable they are of smelling them and detecting them in the environment. This is something that's going to be linked to their genetic underpinnings. So the way we usually think about this is not necessarily that the collective behavior is heritable per se, but the way the individual react to each other and process information that they detect in the environment has an heritable component. And as long as you if you want, keep these pass on these behaviors, this individual behavior to the next generation, then the emergent collective behavior is going to be mechanically present as well, if that makes sense. So you can't really trace back collective behavior to a particular set of genes, but because it's an emergent behavior from the individual behaviors, because the individual behaviors to some extent are based on physiological and neurophysiological processes that are heritable, mechanically, if you want, these emergent layers will exist in the next generation because the underlying layers are heritable.
I understand. So as far as I know, sometimes we find similarities between, at least in certain features, between, for example, human architecture and constructions made by eusocial insects, like, for example, certain species of ant. How do we make sense of that from a biological perspective?
I mean, ants and humans, right? We all, that the thing that makes us similar is that we are very social. We are highly influenced by the behaviors of others around us. We cooperate with individuals around us, and so because of that highly social structure, you will find similarities in the collective behaviors of these different species. Now, this being said, right, I'm not saying the ants are behaving like the humans and humans behaving like the ants. We both have like different constraints and different abilities to modify our environment, also different abilities to sort of isolate ourselves, if you want, from the social world. Like human beings, we are less social, if you want. We're less socially dependent on others. We can do things on our own from time to time, at least. While ants are more like the survival of the ant colony depends on everybody working together. But because we have all that tendency of being influenced by the behavior of others, you will find in both systems these mechanisms of information propagation inside the group. And in some cases, this mechanism will lead to exactly the same type of result. So the same way the ants use pheromone to attract other ants toward food sources and then use that social information to select the best food source in the environment, we use social information to guide also our individual choices. And if the system of recommendation is properly set up, the group will also be able to select the best product. So this is the same principles we apply to two different species, but it will lead to the same result, which is the appearance of a collective selection of a particular product or particular food source. Mm-hmm. So yes, there will be parallel just because we are social, and therefore anything that is transmitted through social means is going to potentially have the same effect in both populations.
Right. So you've been using the word or the term information. Could you explain a little bit better what is information from an evolutionary perspective?
Oh well, do you have just an hour to talk about that? No, information is it's a complicated concept. I mean, I'm not a philosopher of information theory, so I won't pretend that I can give you a good definition of information. But in its, I guess, simplest form, when we're talking about information, is it's not something you can see, but you can see the result of it. And so when we talk about information and you see two objects and there is a signal, so for instance, a pheromone, my voice coming toward you, etc., that goes from one object to the other, and that signal modifies the behavior of the second object, then we make this sort of like mental leap that signal was carrying information, because that signal was capable of modifying the behavior of another object. And so that's what when I talk about information, that's what I call. I talk about a signal that went from one individual to another and that modified the behavior of the receiver object, if you want. Mm-hmm. So it's someone had a really good definition. It's a difference that makes a difference, right? So,
I understand. So, but talking again about collective decision making, because earlier I've asked you about examples of biological systems where we find swarm intelligence. Are there particular aspects of a species sociality that have to be set in place for it to be able to have collective decision making?
So, I guess there's two things, right? The first thing is every time you're going to be putting a bunch of objects that can interact with each other, exchange information, influence each other, you put these objects together, you'll have some emergent properties appearing out of it. Now, the question is whether these emergent properties are capable of solving a problem for the object, or in my case as a biologist, will allow them to increase their fitness. Right, so will these emergent properties make it that the individuals inside the groups are more likely to pass on their gene to the next generation? And so when we talk about, if you go back to the problem of collective decision making, right, the question is whether by interacting with each other, the group is going to be more capable of identifying in the environment resources that will allow them to increase their fitness. And by fitness, it can be anything. If we talk about humans, we're not necessarily talking about genetic fitness or like next generation kind of things, but increase our ability as a society to, improve our wealth or improve the well-being of our societies. So Now, this being said, as I said, if you put things together and they can interact, something is going to happen. No, what you're asking me, I think, is are there like particular features you need to have so that these emergent properties benefit the group? And the question is, I mean, it's yes and no. Essentially, as soon as you have the possibility of interacting, you have everything you need to be able to do collective decision making or any form of collective behavior. The thing is, what matters is how the interaction and the way you react to interactions are tuned, evolutionary speaking, so that it gives you the best result. Right? So, as I said, you put a bunch of objects that can interact with each other, you get emergent properties. But these emergent properties, most of the time, if you don't like carefully control how you react to this interaction, 99% of the time, it leads to catastrophic results. And so what evolution is doing is tuning the way we react, how much we react to social information, how often do we rely on social information versus the information that we have gathered ourselves, how much do we pass on some of our social information. And so what matters is not necessarily the fact that we can pass on social information, is how much do we pass it on, how much do we react to information we receive, and how do we react to it, right? So the answer to your question is it's going to depend on what the problem is and what you're trying to solve. But the answer is going to be also, it will require some form of regulation mechanism or something that will make sure that the individuals don't overreact or underreact to the information that they're receiving. I mean, the case of overreaction, I mean, we see this every day in our social media. You put out a fake piece of information, but that's very attractive visually, for instance, or that reinforce your own beliefs, and then you're going to be likely to share it and react strongly to it, and people who agree with your beliefs are going to react to it strongly and share it, etc., even though that might be a completely wrong piece of information. And so the problem here in these social systems, in this social media, is that we have not evolved, if you want, or we have not created yet the mechanism that allow us to regulate our response to that kind of information. Like, I get information, it creates a lot of emotions in me because it agrees with my beliefs, for instance, so it's very emotional. There's no mechanism that prevents me from immediately sharing it and then propagating that false information. Well, if you look at biological systems that have evolved to function properly collectively, they have this mechanism in which, okay, if I receive an information from social information that is contradicting some facts that I have gathered independently, there is mechanisms inside this organism to sort of balance how much do I trust the information I've gathered firsthand versus I trust information that I receive from other individuals. And that balance is very important, because otherwise, when that balance is broken, that's when the system goes from like everything works well, we make the best optimal decision, to we all end up running into a wall together. So the answer, I guess, is you need interactions, the passing on social information, and you need mechanisms that allow you to regulate your response to this social information.
Mm-hmm. What about something like social cohesion? And I mean, what does that mean here exactly?
I mean, whatever you want, I guess. So there is one thing, is a lot of these mechanisms of collective decision making in swarm systems are based on mechanisms that reduce, if you want, the diversity of opinion, that will make everyone align and reach a consensus on a particular option. Now, this is really good. Like, if you're trying to search for the best food source in your environment or the best laptop on Amazon, it's a really good mechanism, because you want to have a system that can converge toward the best option, and everybody aligns and agrees that in the end it's the best option and we should exploit that. The problem is when the objective benefit of the the opinion that you all agree on is not clear. So when we talk about things like ethical problem, right? An ethical problem, an ethical issue, doesn't necessarily have a clear benefit, like I get more food or I get a better laptop. And in the end, you end up with a bunch of different opinions, which is fine, that are on one side or another of the ethical question and that are more or less close to the middle ground or more further away. But because of this same mechanism that allow us to converge toward, let's say, buying the best laptop or getting the best food source, if we have the same thing that has us converge toward opinions related to ethical problem or moral questions that don't have an objective value, in the end, you may end up picking something that you may end up essentially having reduced completely the diversity of opinion on the problem and get locked into cultural and moral situations that becomes very hard to get out. And that is a problem. I mean, it's something called groupthink. You may have read about this, but there's just this idea that we just narrowing, everybody narrows their opinion toward one particular specific opinion, which is good if that opinion is about something that has an objective value, but can be problematic when we're talking about moral values or ethical values, which may, change with the history and around the course of time. And then when we're locked in these opinions, it becomes very hard to get out of it. Mm-hmm. And it's, yeah, go
ahead. I was going to ask you, is decision making possible without a brain?
Oh, but again, yes, it depends on how you define, as I said, it depends how you define decision making. And the type of practical definition that we use, which is about we observe an object, an agent, and we are trying to figure out if that agent, if you give it the choice between two options, does it end up at one option more often than chance, which is the best we can do in the lab, right? In the experimental context, that's the best you can do when you can't talk to the organism. But then you'll see that any organism on the planet will make, quotes, decisions under that definition. So you can take a bacteria, you can take a slime mold, you can take a plant. You'll see that their movement or their location over time is not changing randomly. And even if the environment is fixed, while the environment is necessarily pushing the organism left or right, it's not a physical processes through the action of the organism, it ends up at a place. And if you were to repeat the experiment again and again and again and again, it would end up at that place more often than by chance. And so, yes, under that definition, you can have decision making without a brain because bacteria can do that, plant can do that. Pretty much any organism that has sensors and an ability to move or change its configuration will be able to do that.
Mm-hmm. So, I mean, since you're even mentioning bacteria, for example, I asked you about the brain, but an organism doesn't even need to have a nervous system for it to make decisions, correct?
No, because, I mean, the way I see the problem of decisions, right? It's a question of you get information from the environment, you process that information, and the result of that processing changes your behavior, right? And so any organism that has a mechanism by which it can process information will be able, if it's tuned properly by evolution, to choose more often than not the best option, for instance. And if you look at a bacteria has sensors at the surface of a cell, right? A lot of molecules that are capable of binding to molecules that they find in the environment. These molecules, these receptors, will connect to processes inside the cell that will create cascades of biochemical reaction that will change, for instance, the production of certain protein or the expression of certain genes. And by changing this, changes the behavior, so the behavior of the bacteria itself. So inside each cell, there is a lot of mechanism that allow to transform an information into an action. And if that process of processing, that information processing system through evolution more consistently manages to change the behavior of an organism so that it benefits, or it gets away from dangers, or benefit and go toward a better environment, then yes, you have a mechanism of decision making that didn't rely on neurons and having a brain.
Does that tell us anything about embodied cognition, for example?
I mean, I guess the question is there, I don't know of any example of non-embodied cognition. So if you can find me an example, maybe we can discuss that. I don't know if it tells us anything about it, because I don't know what not embodied cognition would look like. Because from our point of view, there's no way to determine that an organism or system has performed any form of cognitive task without seeing an output. And therefore, if you have an output into the real world, you need to have a body or something that is going to act on the environment. So it has to be embodied, because if it's not embodied, you never see the output, and therefore you can never know if there is cognition in that system. Right? If I give you a black box, there may be very complicated circuitry in there that can process information, but if you never see the output of that processing, then you don't know that it has existed. And so I don't think, I mean, it's a nice philosophical thought. There's a black box somewhere that may be thinking and maybe receiving inputs, but never produces output. But then from our point of view, that black box is, you can't say if it's cognitive or not cognitive, because you can't observe its action on the world.
When it comes to human societies particularly, how do human crowds produce collective intelligence?
In the same way any other collective system does, right? I mean, I guess yes and no. So you will have that form of swarm intelligence that we discussed, which is that decentralized, unplanned form of collective behavior. And this will exist, again, that will exist in any system where you have enough objects that can interact often enough with each other and react to each other often enough. And then in some cases, as I said, it will work very nicely. Again, the example of recommender system is an example of that swarm intelligence in humans that works very well most of the time. And in some cases, it will go catastrophically. Traffic jam on the turnpike here in New Jersey is a result of self-organization gone wrong. So it's a form of collective stupidity, if you want, or swarm stupidity. But collective intelligence is a larger umbrella than swarm intelligence. Swarm intelligence is collective intelligence that is done in a decentralized, unplanned way. Collective intelligence in the literature, essentially, people will define this as simply the fact that by working together, individuals or the group achieves something that is greater than the sum of the parts. And that can be achieved through mechanisms that are completely centralized. So that can be, most companies in the world have a hierarchical structure that allow to organize the work, distribute the tasks, optimize the distribution of tasks in a way that is maybe more rigid, but also more efficient and more reactive. And so that's a form of collective intelligence, because the company can produce things that any single individual on their own will not be able to do, because that would be too complicated. So that's a form of collective intelligence, but it's not a form of swarm intelligence, because everything is planned and structured hierarchically. I don't know if that makes sense, but
yes, it does. But do we see the same kind of phenomena in artificial intelligent systems?
So you need to be a bit more precise on your question here. That's...
okay. The things like collective intelligence, swarm intelligence.
I mean, there is an entire field of, so the swarm intelligence, the field is actually mostly an applied field, with people having developed algorithm for optimization, for instance, using, taking inspiration of how the ants find food sources to optimize path on the path that information takes on communication network, or how we should route the planes or trucks that are transporting merchandises. So that's one part of swarm intelligence, which is trying to use what we learn from this natural swarm system to create optimization algorithms for these complex questions where lots of moving parts are interacting with each other, and we don't necessarily have time to plan optimally exactly what's going to happen because there's also a lot of unknown in the system. And then there is another big part, which is swarm robotics, which is trying to bring these algorithms, these optimization algorithm, to robots that can act in the real world, and that will be capable of working together and cooperating to achieve a greater outcome together. Swarm robotics it's one of these disciplines where it started like a long time ago, like sometimes in the 90s, early 90s, and it hasn't yet come up really in applied form in the real world because there hasn't been a situation where it was needed. But there's like something that's going to become necessary, like when we have all these autonomous cars on the road. Autonomous cars essentially a robot. If you want to be able to use that to actually improve things like traffic on the roads and reduce the pollutions by trying to optimize where the cars are going to reduce the amount of gas or electricity that they use. You won't be able to do this with a centralized system that optimizes the path of every car individually at the scale of an entire city or country. And so there will be some application there where these like swarm systems, these systems that are capable purely autonomously in a completely distributed fashion to optimize their behavior, will probably have a lot of application in that field. And there is also applications that are being developed in the real world. For instance, in warehouses, we're talking about Amazon, but other places do that, where they have fleets of robots that go and essentially pick up products. They go inside the warehouses and then they will grab the shelves that contain the product to bring them to the workers that are packaging them. And part of the way these robots are performing their tasks is also in a form of decentralized way, where they react to what's happening and then as a collective optimize their actions in an autonomous fashion without the need for necessarily having a central computer that is guiding every single action. Because if we had that, any problem that happens in the system, then the problem propagates if you try to fix it yourself, right? It's like you try to fix this and then that breaks that. And so now you try to fix that, but then that breaks another thing, etc. But with a system that is decentralized, something breaks here, the rest of the system can act without having to wait for that part to be fixed. Mm-hmm. And so there are applications in the warehouse world, and there will be application in the autonomous car industry of this swarm robotic stuff.
Mm-hmm. Can we learn about natural intelligence and natural decision-making by studying robot behavior?
It's a good question. Historically speaking, right, most of what's been done in robotics and swarm robotics is taking inspiration from a natural system, bringing this principle to an engineered system in order to solve a human-specific problem, right? So historically, right, the flow of information or the flow of knowledge has been going from nature to applications, but not necessarily the other way around. Mm-hmm. Now, this being said, in the process of transferring that information to the engineering side, you have to make abstraction. So you have to start developing models and abstraction, because then you can use this abstraction to optimize the behavior of your robots, for instance, so that they do what you want. But we can also use these abstractions, these models, and then turn them back toward nature to figure out, in that space of optimal possibilities that we can get out of these models, where do the natural system fit? And so, even though it's not the natural flow of knowledge to go back toward biology, the tools that are developed by engineers in the process of transforming that biological knowledge into engineering knowledge, we can reuse them, and we reuse them very frequently in the form of these abstractions that allow us to explore the realm of possibilities that this swarm system can reach, determine, for instance, where they will behave optimally for achieving particular tasks, and then determine whether the biological system fits within this optimal configuration of the parameters, or whether they actually are off these optimal parameters. Mm-hmm. So I don't know if that answers your question, but so we don't necessarily learn anything by looking at the robots, but the tools that are developed to get to the robots are extremely helpful for us to understand better our biological systems.
Mm-hmm. When it comes to humans, particularly with the kind of research that you do you think that it allows for us to have a better understanding of how human societies get organized?
Yes, I mean, as I said, right, you will have in human societies swarm intelligent processes at work, and then you will have also these other form of collective intelligence, more organized, planned. And this is not the purpose of swarm intelligence. We don't look at these organized and planned systems. But what's interesting is, it's called swarm intelligence because people are looking at this to get intelligent solution to a problem. But when you apply the same tools to human societies, in a lot of cases, you realize that a lot of the societal problems that we have, I talked about traffic jams and flow of fake informations and on social networks. These are problems that are caused by the same principle that make an ant colony being able to optimally forage in its environment. So we have the same principle, but because the parameters are, or the way we react to this information is not, hasn't evolved, if you want, to mitigate the negative consequences of these. I mean, if you want to, traffic jams are a problem. It's a modern problem. There was no traffic jam in the 1800s because there was no car and there was not enough traffic on the roads to create traffic jams that became a economic problem for our societies. So we only had 100 years to adjust to that, if you want, and we haven't changed our behavior that much in that meantime. So what's interesting is when we look at human societies through the lens of swarm intelligence, we actually it's very useful to actually identify what are the root causes of some of these, mass problems that we create in our societies because we are jam-packed with each other into cities, and haven't yet. I mean, it's probably in the process of happening. Culturally, we're changing and our behaviors are changing, but we haven't yet found the right way of smoothing out all these interactions so that problems like traffic jam, fake information, mass panic do not spread. But we can use the same tools as we use to study animals to realize where humans are in this, realm of optimal possibilities, and to see that sometimes we are very far from how we should organize ourselves.
Mm-hmm. So just to talk about a concrete example, I know you've studied human crowd motion. I mean, it is mainly driven by self-organized processes based on local interactions among pedestrians, right? I mean, could you explain that?
Yeah, so the funny thing is pedestrian crowds are fairly efficient, very, very efficient actually. But we can talk about this. But yeah, in human crowds, right? Like when you walk in a very busy street, you have an objective, right? So you're trying to get somewhere, and you plan this in your head. Like I need to go from A to B. I have a path, but along that path, you bump into obstacles, whether they are like objects in the streets or other people walking toward you. And when there are other people walking towards you, we have developed social conventions on how to avoid people. I mean, you live in continental Europe, and so most of the time, if you go in the street, if you observe how people avoid you when you walk in the street, you'll realize that most of the time they are going to pass you on your left side, and you are going to step aside or move a little bit toward your right side to avoid them. And these social conventions actually have an effect that it fluidifies the traffic, because it ends up creating lines, separate lines of movement, with individuals moving in one direction being on one side of the sidewalk or the road, and the other people being on the other side. And that limits the head-on collisions between individuals, so the need to slow down to avoid collision, and that fluidifies the traffic. So that's an example of actually where it works pretty well, where we have developed these social conventions that allow us to fluidify our interactions. But then you take the same individuals and then you put them in a car, and but there's almost no head-on collision, right? Most roads you're moving, you never have to avoid a car coming in front of you. So you're literally going in the same direction as everyone. But because everyone doesn't want to go at the same speed, everyone doesn't want necessarily to follow the rules exactly of traffic, etc., that creates perturbation that then cascades throughout the system, and then generate traffic jam at some point. I mean, you may have heard of the phantom traffic jam effect, which, so it's very simple, right? You have cars going on the road, and then you have a car that goes slightly slower than the car behind it. The car behind, to avoid collision, is going to have to slow down to avoid collision, but it's going to slow down a little more. So the speed of that car coming behind is going to have to reduce a little more than the car it's trying to avoid collision with, which means that this car now is going a little slower than the car in front of it, which means if there's another car coming, it will have to slow down and be a little slower than the car in front of it, etc., etc. And if you propagate, if you have enough cars following each other, you propagate that over this length of the car, at some point someone is going to be stopped.
Mm-hmm.
So even though everybody is free to move, because we just react by slowing down just a little bit more, if you propagate that enough, at some point someone is stopped and a traffic jam starts beyond that. That doesn't happen easily in pedestrian crowds unless you reach extreme densities. But like densities at which like people are literally packed against each other, in which case physics takes over and it's nothing to do with behavior anymore. Mm-hmm. But in cars, we have that suboptimal way of reacting and adjusting our speed to the person in front of us that makes it that it propagates backward, and then somewhere along the road someone is going to stop and a traffic jam is going to form behind.
Mm-hmm. So just one last question. Does the kind of phenomena that you study in human societies would allow for us to have a better understanding of some more major things, like, for example, how political systems develop, or even to have a better understanding of what human culture is and how it develops and evolves? I mean, some more major things like that.
Yeah, so the answer is yes, to some extent, right? Human societies are part swarms and part hierarchies, right? And so you have to understand how these two things interact with each other. So some phenomenon are going to be, cultural norms, for instance, can emerge through self-organization, through the swarm mentality, if you want. We adopt the behavior of other people around us, like fashion, for instance. You see people dress a certain way, and then you adjust and you change your fashion around time. So we have this behavior that propagate these social norms, this political norm that can propagate inside the population. But they can be also controlled from the outside. So for instance, if we talk about fashion, right? Fashion is not completely organic, right? The big companies can push certain fashion trend because they want to be able to sell more clothes, so they will artificially push or accelerate the process of changing fashion or of the fashion changing so that we can sell more and more product. The same way on the political spectrum, we can make use of social media to push some ideas that will and that have an influence on polarizing, for instance, the political discourse. And because you, again, tend to agree with your friends, and then if all your friends are, let's say, Democrats, all your friends are Republican, and then you only talk to your friends that are Democrats, or only talk to your friends that are Republicans. I'm talking about the US, I guess, maybe doesn't apply to Portugal, but you end up with these sort of silos where people are only talking to each other and reinforcing their own opinion, but also you can, from the outside, push more and more radical ideas on both sides, and so radicalize even more even each bloc, and push them away from each other by saying the other side is evil, right? And so that's, I guess that's the major challenge. The major challenge for our societies is we can't do without these swarm intelligence processes. They exist. They are in the society. They are like part of our societal living. But they also can be manipulated for economical gain, for political gain, for all sorts of reasons. So we can manipulate the way cultural norms are changing and political norms are changing. And the question is going to be, how do we, do we realize that this is happening? Are enough people realizing that this is happening? And what do we do as a society to protect ourselves from that form of collective manipulation? And that is a big question, because there is not an easy answer to how do we protect society and systems from the injection of information that is pushing people apart or guiding their behavior in ways that sometimes they feel completely natural to us. You see the information, you just absorb it, and you modify your behavior, and you don't necessarily realize at the global scale what it changes at the societal level. So there is a movement. There's been I don't know, I can send you that after if you want. There's been a paper about a year ago that is starting to call for, so put together by a bunch of scientists in the field, that is trying to call for a more systematic study of how social networks in particular, but any form of social transfer of information in human societies, how can we make them more ethical, in the sense that they will prevent this groupthink from happening, or limit the groupthink from happening where diversity of opinion might be important. Right, when we talk about problems about racial disparities, for instance, or socioeconomical disparities, there need to be diversity of opinion in a problem like that, because you need to be able to hear the voices of the people that are in the minority and may be oppressed by the majority in some cases. So in these systems, you want to have a way to make sure all opinions are heard, while not getting rid of the fact that in some cases having the possibility to narrow opinion on an optimal solution is a good thing. So again, like we talk about selecting the best product or best technology, it's a way where it's actually a good thing to be able to come to a consensus, or electing, the best leaders for countries. It's a place where it's important to be able to reach consensus. But how do you balance these two things, where in one case this ability of everybody getting to a consensus is positive, and in other cases is negative? How do you make sure you tune that properly depending on the context? Is a very important question that we will have to figure out if we don't want essentially a democracy to collapse. I'm a bit over dramatic, but if you end up with a country where you only have two options and there's no more possibility to hear the diversity of opinion that are between the two options, well, you're not that far from it's not a dictatorship yet, but it's not that far from it, because you essentially have a just a duopole in terms of moral and ethical opinions, and that's kind of problematic.
So, Dr. Garnier, let's end on that note. Just before we go, where can people find you and your work on the internet?
Lots of places. I mean, I guess if you type my name on Google, I'm like the first 3 pages of it. But otherwise, they can go to our website, which is theswarmlab.com, all attached. And then I'm on Twitter as well, SGM, and then my last name, Garnier. And yeah, these are the 2, I guess, website to get information about what we do, and then Twitter is a good place to contact me if you're interested. And then otherwise, I mean, you can always send me emails, but I'm not particularly good at responding to my email very quickly, as you know very well.
Okay, so thank you so much for taking the time to come on the show. It's been a real pleasure to talk to you.
It was my pleasure. Thank you very much.
Hi guys, thank you for watching this interview until the end. If you like what I'm doing, please share it, leave a like, hit the subscription button, all of those things you already know. And please consider supporting the show either on PayPal or Patreon. All of the links will be in the description box of the interview, starting at $1 per month, so it would be a great help. This show is brought to you by Enlights, Learning and Development Done Differently. Check their website at enlights.com. I would also like to give a huge thank you to my main patrons and PayPal supporters: Karen Litske and Blanchett, Pererga Larson, Lau Guerrero, Francis Ford, Hans Frederick Sunder, Ricardo Vladimiro, Greg Healy, Adam Castle, Olaf Alex, Jonathan Wiesel, Jacob Klinkby, Matthew Whittingbird, Arno Wolf, Tim Hollis, Eric Alenia, John Connors, Paulina Barron, Philip Force Connolly, Jerry Mueller, Herbert Gintis, Rutger Vosbo, Weingard, Rebecca Newberger Goldstein, Dan Demetrio, Robert Windager, Rui Narcio, Arthur Coe, Zup, Marco Neves, Colin Holbrook, Susan Pinker, Bernardo Seixas, Pablo Santurbano, Simon Colombo, Jorge Espinha, Phil Kavanagh, Mark Blythe, Roberto Inguanzo, Michael Stormir, Eric Neumann, Samuel Andreev, Tiago Nunes, Bernard Ugni, Alexander Dunbauer, Fergal Cusson, Evan Bodrenko, Al Herzog, Don Ross, Jonathan Librant, Oslam Bullitt, Nathan Nguyen, Stanton T, Samuel Correa, Eric Hines, Mark Smith, J.W., João Eira, Tom Hummel, David Sloan Wilson, Yacila Dez Araújo, Eden Solon, Romain Roach, Dmitry Grigoriev, Diego Londoño Correa, Tom Roth, Yannick Punter, Adana Rusmani, Charlotte Bliss, Nicole Barbaro, Adam Hunt, Pavel Ostazewski, Nelek Bach, Catherine and Patrick Tobin, Al Ortiz, Guy Madison, Gary G. Hellman, João Linhares, Lida Cosmidis, Sam Afzal, Adrian Yegi, Nick Golden, Paulo Tolentino, João Barbosa, Jules Price, Edward Hall, Edin Bronner, Franca Bortolotti, Gabriel Pons Cortez, Ursula Litske, Denise Cook, Scott Zachary Fish, Tim Duffy and Trader in NYC. My producers Izar Webb, Jim Frank, Lucas Stafiniak, Ian Gilligan, Luis Caetano, Tom Vanagdam, Curtis Dixon, João Linhares, Benedict Mueller, Vega Guidi, Sardus France, Thomas Trumbull, and Nuno Welder. And my executive producers Michel Rugieski, Rosie, James Pratt, Matthew Lavender, Sergio Codreanu, and Bogdan Kanivets. Thank you for all.